Welcome to Structural Analysis 2 video series Analysis of beam by slope deflection method. Lecture outline: numerical problem on sinking of a support in a beam. Problem statement as follows: analyze the continuous beam shown in figure by slope deflection method if a joint B sink by 10 mm. Flexural rigidity EI is equal to 4000 kN meter square. Draw bending moment and shear force diagram. In the given figure, AB span loaded with the 20 kN per meter UDL. Span is of 8 meter. Moment of inertia is 2I. BC span loaded with the 60 kN point load at the center. Moment of inertia is I, and the span is of 4 meter. B and C are a roller support, and A is a fixed support. First, let we find out the degree of kinematic indeterminacy. At a roller or hinge support, there is rotation. So, theta B and theta C are the 2 degrees of freedom here. So, dki or degree of freedom is 2. At a fixed support, there is a 0 degree of freedom. Now, find out a fixed end moment for each span. Treat each span as a fix and find out the fixed end moment. The formula for UDL is WL square by 12. W is 20 and span is 8 square divided by 12. It becomes 106.67 kN meter. So at A, the moment will be anti-clockwise sense. So our sign convention is positive, plus 106.67 kN meter. And at B, it is in a clockwise sense. So sign convention is minus 106.67 kN meter. Now for span BC, consider B and C both are the fixed support, and find out the moment at friction moment at B and friction moment at C. At B anti-clockwise you have to take plus, and at C the clockwise you have to take minus sign. And the formula for point load at the center, WL by 8. W is 60 into 4 is a span divided by 8 is equal to 30 kN meter. So plus 30 kN meter, MF BC and MF CB is minus 30 kN meter. Now in second step, apply the slope deflection equation. So the equation is MAB is equal to MFAB plus 4EI by L theta A plus 2EI by L theta B plus minus 6EI by L square into delta. Now here let assume the deflection delta in the downward direction and let consider it as a positive. So when deflection occur in the downward direction at B, this AB will get deflected and the moment will be created at B in the anti-clockwise direction. Start from the tension side. At the bottom there is a tension and move about the joint B in a anti-clockwise direction toward the open end. Same moment will be created in a same sense anti-clockwise direction at the far end. So at the far end, top is in under detention. So start from the top about A in the same sense in the anti-clockwise direction. So for anti-clockwise direction, our sign convention is positive. So here you adopt positive sign for the moment due to the sinking of a support. So now put the value. MFAB is 106.67 plus 2E into 2I. Moment of inertia for the AB is 2I divided by 8. 8 is a span into theta B plus 6 into 4000. EI is 4000 and moment of inertia is 2. So multiply by 2 divided by 8 square. Span is 8 into 10 divided by 1000. Convert into the meter. Now theta A will be 0 here because A is a fixed support, so no rotation. So finally, MAB is equal to 106.67 plus 0.5 EI theta B plus 7.5. Simplifying, MAB is equal to 114.17 plus 0.5 EI theta B. Let's say equation 1. Now apply the equation for the end B. Now moment sign convention is positive. For both ends, it create in anti-clockwise direction. Now theta A is, again it is a fixed support, so theta A is 0. Now putting the value MFBA, we minus 106.67 plus 4E into 2I divided by 8 into theta B plus 6 into 4000 into 2 divided by 8 square into 10 divided by 1000. We are calculating for span AB but at the end B. So moment of inertia again 2I, that's why 2 is here. Now simplify, we have MBA is equal to minus 11.17 plus EI theta B. Let's say equation 2. Now let's consider span BC. Now due to the sinking of a support, you mention here, the moment will generated from the bottom and it will rotate about B toward the open end and it is in a clockwise direction. So same sense will be maintained at the far end C. Start from the tension side, top under tension, here bottom under tension. So start from the top about C, rotate about C and it will again maintain the clockwise sense. So for both end clockwise sense, so our sign convention is negative now for the uh, moment due to the sinking of a support. Here you have to take now minus for the both end now. So let MBC is equal to MFBC plus 4EI by L into theta B. Now again first letter is B. So for first theta B you have to take 4. Now second letter is C. So for theta C you have to take 2 multiplied by the 2. Likewise you have to remember 2 EI by L theta C plus minus 6 EI by L square into delta. Putting the value MBC is equal to 30 plus 4 EI by 4 is the span into theta B. Now theta B and theta C will be here because at B and at C there is a simply supported or roller support. 2 EI by 4 into theta C minus. Now why minus? Because the moment is in a clockwise sense. Minus 6 into 4000. Now moment of inertia is I. So EI is equal to 4000 divided by 4 square. Span is 4 into 10 divided by 1000. So by simplifying we have MBC is equal to 15 plus EI theta B plus 0.5 EI theta C. Let's say equation number 3. Now let's find out for the MCB is equal to MFCB plus, now again here the first letter is a C, so multiply theta C by 4 and second letter is B, so multiply theta B by 2. So MFCB plus 2 EI by L theta B plus 4 EI by L theta C plus minus 6 EI by L square into delta. Now we know the sign convention is our sign sense is clockwise, so minus sign is there. Now putting the value minus 30 plus 2 EI by 4 into theta B plus 4 EI by 4 into theta C minus 6 into 4000 minus 6 4000 divided by L 4 square, length is 4 into 10 divided by 1000. So MCB is equal to minus 45.5 EI theta B plus EI theta C. Let's say equation number 4. Now there are two degree of freedom, so we should know the two equation of equilibrium. So first one is at C the moment is equal to 0 and at B the moment coming from the either side their summation should be equal to 0 to maintain the equilibrium. So MBA plus MBC is equal to 0. Now putting here the previous equation calculated from the slope deflection equation. So MBA is minus 99.17 plus EI theta B plus 15 plus ei theta b plus zero point 0.5 ei theta c is equal to 0. So we have 2 ei theta b plus 0 point 0.5 ei theta c is equal to 84.17. Let's say equation 1. Summation of moment is equal to 0. So mcb is equal to 0. So mcb is 0 0.5 ei theta b plus ei theta c is equal to 45. Let's say equation number 2. Now solve these two simultaneous equations. We will get ei theta b and ei theta c. So we have ei theta b is equal to 35.24 and ei theta c is equal to 27.38. Now substituting the value in the slope deflection equation, we will get MAB. We know that 114.17 plus 0.5 ei theta b. Putting here ei theta b as 35.24, we have MAB 131.79 kilonewton meter. Now we know the equation of MBA from the slope deflection equation is equal to minus 99.17 plus ei theta b. Putting ei theta b, we have MBA is equal to minus 63.93 kilonewton meter. Same way, let's calculate for the BC. MBC is equal to 15 plus ei theta b plus 0.5 ei theta c. Putting the value of ei theta b and ei theta c, we have MBC is equal to 63.93 kilonewton meter. Now the next equation for the end C, MCB is equal to minus 45 plus 0.5 ei theta b plus ei theta c. Putting the value, we have MCB is equal to 0, and it matches with the criteria, that is for simply supported end, the end moment is always 0. So that means our calculations are correct. Now the shear force calculation. First, let's find out the reaction due to the given loading. Consider each FBD of each span. So 20 kilonewton per meter UDL is there for the 8 meter span. So 20 into 8 divided by 2, having 80 kilonewton at each end in upward direction. And for 60 kilonewton load which is acting at the center, divided by 2, we having a 30 kilonewton reaction at each end. So these are the reaction due to the loading. Now find out reaction due to the unbalanced moment. So at A, the moment is 131.79 kilonewton meter, and it's in a minus sign, and it is in a clockwise sense. So this moment 131.79 kilonewton is a positive, so it would be in a anti-clockwise direction. So in anti-clockwise direction, our sign is positive. Now at B end, it is in a minus, so it is in a clockwise direction, 63.93. Now take a difference between these two divided by span. Now show it below the maximum moment. So maximum moment below it you show first, and it should be get added into the 63.93 kilonewton which is in a clockwise direction. So show arrow up, and it value will be 131.79 minus 63.93 divided by span become 8.483 kilonewton. At the far end, you have to show same magnitude in the opposite direction or downward direction, opposite to the first one. Now this next span, the moment is 63.93 kilonewton, and it is in positive anti-clockwise direction. At C end, simply support is so 0. So 63.93 divided by span 4, we will get 15.98. So locate below the maximum moment. Maximum moment is 63.93. So locate below first maximum moment. Now to decide the arrow. So how to decide? So this moment is in a anti-clockwise direction. So here the moment should be in a clockwise direction to balance this one. So show the arrow now up, so when it rotate, it will get added here and create the moment in a clockwise direction. Now at the far end, same magnitude you have to show, but arrow you have to make in opposite direction, that means in a downward direction. Now next step is do the addition of reaction. First one is 80 kilonewton upward plus, next reaction is a plus 8.483, so finally we have 88.48. Now next is 80 kilonewton up minus this 8.483, so we have plus 71.52. Then plus 30 kilonewton upward plus 15.98 become 45.98 kilonewton, plus 30 kilonewton minus 15.98, so it become plus 14.02 kilonewton. So these are the total reaction or final reaction. So net reaction at B will be the addition of these two, and it will be come out to be 117.117.5. This one is a total net reaction at B, or total reaction at B coming from the either side span. Next is the shear force diagram. So at A the reaction is 88.48 kilonewton upward, then minus 20 into 8 we having a minus 71.52 UDL, so inclined line. Then plus 117.5 we having a plus 45.98, no load, so straight line. Then minus 60 we having a 14.02 minus, then here is again plus 14.02 and we will get 0 here, no load, so straight line in between these load or reaction. Okay, so this is about your shear force diagram. Now let's draw the bending moment diagram. First let draw the free bending moment diagram. Let consider simply supported end span for 20 kilonewton per meter UDL. So our equation is WL is L square by 8. So we having a W is 20 into 8 square divided by 8. So we having a 160 kilonewton meter moment. And next one is a point load is a 60 kilonewton, and formula is WL by 4. So we having a 60 kilonewton meter moment. So it is in a triangular fashion, and for UDL it is a second degree parabolic curve. Now next is draw the for the end moment. At A end moment is a positive 131.79 kilonewton meter. So keep a pen close to A and rotate in an anti-clockwise direction. After one rotation, arrow coming up, so you have to show up. At C the end moment is 63.93, so its value is minus, so you have to rotate about B in a clockwise direction, and after one rotation arrow coming up, so you have to show up. And at C the moment is 0, so now then you have to join with the line. It may be inclined or straight line, so it is about your end moment diagram. Then a portion which is not overlap, that you have to hatch, and portion which is overlap, that shown in a white color, this is a portion which is not overlap, that you have to hatch. Okay, so let's stop here. Thank you.